Hi everyone, welcome to my channel. We are going to learn about the laws of logarithms today. The first rule is, if you have two logs with the same base, that is log of x to a base of a plus log of y to a base of a, this will give us log of x times y to a base of a. The key is that it has to be of the same base. You can only multiply the terms when you have the same base. Let me show you an example. If you have log of 100 with the base of 10 plus log of 1000 with the base of 10, this will give you log of, you have to multiply the two terms, 100 times 1000 will give you 100,000. 1, 2, 3, 4, 5 to a base of 10 as well. But how do you know it's true? You can check your answer by evaluating the logarithmic expressions. So this equals to, what does this evaluate to? We know log of 10 to the power of 1 gives us 10, but 10 to the power of 2 gives us 100. So this actually equals to 2. This thing is equal to 2. What about this one? We know that 10 to the power of 2 is 100. That's not our answer. But 10 to the power of 3 gives us 1000. That means the answer to this term is 3. So 2 plus 3 should give us 5. Now let's check if this thing equals to 5 as well. Then it will prove our formula. Let's look at this. 10 to the power of 3 is 1000. What about 10 to the power of 4? It's 1, then 4 zeros, 1, 2, 3, 4. It's 10,000, not the same. Let's look at the next term. 10 to the power of 5. 1, 2, 3, 4, 5, which is the same thing as this one. So we can say that this equals to 5 as well. It proves our thing. 2 plus 3 will give you 5. That means whenever you add two logs with the same base, this equals to the product of these two terms with the base of, with the same base. Let's move to number 2, the second formula. It's kind of similar. If you have log of x with the base of a and you subtract another log of y with the base of a, this equals to log of x over a. This time you have to divide when you subtract the logs, but with the same base. Remember, you can only do this when they have the same base. If the bases were different, then you couldn't have done this. Okay, so let's prove this. Log of 8 to a base of 2 minus log of 4 to a base of 2. According to this formula, this will give us log of 2, base 2, 8 over 4. That also equals to log of 2. 8 over 4 is 2. Now let's look at this one. What does this equal to? We know 2 to the power of 3 equals to 8. So this, the whole thing, equals to 3, because 2 to the power of 3 will give us 8. For log of 4 with the base of 2, 2 to the power of 2 equals to 4. So this equals to 2. What about this one? Okay, but before that, we need to subtract and see what we get. So this is 3. 3 minus 2 will give us 1. That means if the formula is right, then this will give us 1 as well. Now let's evaluate this. 2 to the power of what is 2? It's easy because 2 to the power of 1 equals to 2. It's the same thing. So we can say this equals to 2. Sorry. The power of x has to be 1. So this equals to 1. This proves our formula. 3 minus 2 equals to 1. So we can say this formula is correct. And this is our second rule. Let's move to the third rule. Let me use a different color. Okay, so the third rule is, if you have a log of x with the base of a and the power of this log is m, this equals to m. The power goes to the front, then you just have this term, that is log of x with the base of a. Now let's look at an example. Log of 8 with the base of 2. What does this equal to? We already know from this example that 2 to the power of 3 is 8, so this equals to 3. We can also rewrite this equation as log of 2, and then instead of 8, we can write 2 to the power of 3. According to this formula, the power goes to the front and you still have the same value. So we can say if the 3 goes to the front, this will give us 3 log of 2 base 2. Now, what does this equal to? You have to think of a term, like the power of 2 has to be something that will give you 2 as well. This equals to 1 because 2 to the power of 1 is 2. This expression evaluates to 1. And we know 3 times 1 is 3 as well. It matches with this answer. That means this formula is correct as well. And this is our third rule. Now this helps us to get the fourth rule. You can see that if we have the same base and the same number, this equals to 1. Now this is true for everything. So we can write log of a, log of a to a base of a will give us 1. If you have log of 10 with a base of 100, what does this equal to? This has to be 100 as well. If you have the same numbers, 100 to the power of 1 will also give you 100. So this equals to 1. If you have log of 8, this also equals to 1 because 8 to the power of 1 will also give you 8. That's why we use this. Whenever you have the same number and the same base, you can just write 1 straight away. The last formula, the last rule for the day is, okay, different color. Okay, log of 1 to a base of a to a base of anything. This always gives us 0. How? If you have log of 1 with the base of 10, 10 to the power of what will give you 1? 10 to the power of 1 is 10, so it can be that it has to be less than that. 10 to the power of 0 will give you 1. It's actually true for anything. Anything to the power of 0 is 1. It doesn't matter what your term is. 100 to the power of 0 is 1. 1000 to the power of 0 is 1. 525 to the power of 0 is also 1. So whenever you find the log of 1, it doesn't matter what the base is, the answer is always 0. So this is the last rule for the day. Now remember, all of the rules, it also apply to the natural logarithm as well, because I told you in the last video that common logarithm, like normal logarithm and natural logarithm, their rules are all the same. So we can say, let me just quickly show you the rules for natural logarithms as well. If you have ln of x, the ln, this is your natural log, and the base is always e. So you don't really need to write the e. Whenever you have ln, that means we know already that the base is e. If you have ln of x plus ln of y with the base of e, this will give you ln of e x times y. Sorry, why did I write that like in the sky? So ln of xy to a base of e. If you have ln of x minus ln of y, I'm not going to write the base anymore, because whenever you have ln, it just means the base is e, equals to ln of x minus y as well. Number 3, if you have ln of x to the power of m, this equals to m ln x as well. If you have ln of e, this equals to 1 because the base is also e. The fifth one, ln of 1 to a base of e, this gives you 0. Even e to the power of 0 will also give you 1. Okay, so that will be all for today. If you like my videos, then don't forget to subscribe. See you next time. Thank you.